Algebra 2. Hello, it is Masidig. It is in your town Friday. I think the 15th is the date. It is Thursday in my town, and I am recording this so that you have some video to watch for Friday while I have a sub. I'm sorry I haven't been there this week. I wasn't feeling well, and it turned out I had appendicitis, so I had surgery, and I'm sore and I'm tired, but I want you to still have some math to see and to do. So please watch this video. Please do your best. You're going to need your Eureka book. That should already have been assigned. If you don't have your Eureka book yet, pause the video right now and go grab your Eureka book. Okay? If you haven't checked out a Eureka book, I should have a whole bunch on my shelf. Module 3, Algebra 2, just go ahead and grab one, and then make sure you put your name on it, and when I'm back, we'll deal with it on Monday. You want to turn to page 129, and we're going to talk about graphing logs and exponents, and I will have left instructions that you will need a calculator. You want to go ahead and grab a graphing calculator. We're going to do some basic math on this, and you can use some of the calculator stuff for it. We tried to figure out a good way to film this so you could actually see the page, and it just was not working well, so I'm going to copy some of the page on here. So this is page 129. What you're going to see is this nice table, and then what you're going to do is, when we fill out this table, you're actually going to flip your page over to 130, and you're going to graph onto there. So you don't want to graph by hand like I'm going to do. You want to graph on an actual graph paper. It's going to make your life so much easier. But what's really important here is that we're going to graph the function y equals 2 to the x, which is an exponential. And what we're going to see is there's a direct correlation and relationship between these answers and how you would graph its log version, which is this. All right, so what's really, really cool is we're going to have to do really, really basic math, and then we're going to just do a flip trick to get to more complicated math. If you try to graph a log in your calculator the way that it is, it will graph it incomplete. It only graphs to a certain point, and then it gets confused and quits. So I'm going to show you how this works. All right, so your table has your x values. It's got a spot for y equals 2 to the x, so that's where the answer will be. And then it's actually got a spot for the point itself, and I'm going to stick that here. And then it wants us to run through from -3 up to +3. All right, so all we're going to do is we're going to take this and plug it in. You can do this with your calculator, so if you're not sure about powers, 2 to the -3 tells me I'm going to have a fraction. And then 2 to the third is 2 times 2, which is 4 times 2, which is 8. When you graph that, you don't have to be real worried about getting exactly 1/8. But the point then that we're going to graph is going to be -3 1/8. All right, and now I do the same thing with -2. 2 to the -2 gives me 1 over 2 squared, which is 4. Just kidding. That gives me 1/2. And if you aren't sure, go ahead and grab your calculator. This is the same calculator as yours, it's just not yellow. You would go to your 2. Right? And then you want to hit your little caret symbol, and what should happen is you can just put whatever power you want into that, okay? And I don't know if you can see that or not, that's life. But you guys know how to put powers in, so put your powers in. This one gives me the decimal 0.125. It's the same thing as 1/8. If you want to turn it from a fraction into a decimal, hit the math button, and then there's a button that looks like this. If you hit frac, it'll literally just turn that decimal into a fraction. I like fractions when I'm graphing because I think it's kind of easier to think about. But like I said, we're not going to look at our graph and be like, well, that looks like a half and not a fourth. We just want to be in the range of. All right, now we have 2 to the 0 power. Anything to the 0 power is 1. Then we have 2 to the first, which is 2. Then we have 2 to the second, which is 4. And then we have 2 to the third, which is 8. So what's going to happen is we're going to graph these points, and it's going to give us the exponential graph. All right, so I'm going to erase the math. I'm going to leave the points for now. I'm going to pause for a second. You can pause your video here, and what you are doing, in case you got distracted or what was unclear, you are filling out the table on 129. That's literally what this table does, is it has you do the math in the middle, and then it has you list the points. I'm going to leave the points because the points are going to give us our log when we figure out the relationship between them. But I'm going to erase over here so that I can actually graph this picture. So on 130, what you're going to do is you're going to take these points and you're going to graph them into your graph on page 130. All right, you don't want to do this by hand. Mine is not going to look as beautiful as yours does. This is going to go kind of like that. They go from -4 to 8 in the x direction. In the y, they go from -3 to 8. And I'm just going to graph these points. Now, please don't panic about the fractions. This just tells me that my fraction is really close to 0. So when I'm at -3, it's going to be like, I don't know, maybe there. And then -2 and a fourth is maybe there. And then -1 and a half is there. 0 at 1 is really an important one to keep note of because it's our intercept. Then I have 1, 2, 2, 4, and then 3, 8. And what's going to happen is the graph's going to do that. The reason that the graph does this is because this is what's considered exponential. And I don't know if you've ever heard people say it. People like to say, oh man, that grew exponentially. Exponentially means really, really fast. Look at this. 0 went to 1. That wasn't very big, but then when we went to 1, we got to 2. 2 as an x got us to 4. 3 got us to 8. If we went to 4, that would take us to 16. 5 would take us to 32. 6 would take us to 64. 7 would take us to 128. We're only going up by 1 in the x column, but notice what's happening here is because it was 2 to the x, we're doubling every time, and those numbers are getting really big really fast, just like this graph is going up really, really fast. That's what it means when people talk about exponential, is the idea that you're graphing it and it's going to get kind of really, really big really fast. Now, keep your page 130 as your graph. What it wants us now to do is it wants us on page 131 to graph the opposite, which is the log, and I'm going to teach you a trick. This and this are what are called inverses. And what that means is that they are opposites of each other in a relationship. And what they're going to do is they're going to cross what is called the line y equals x, which you don't have to draw the line y equals x. I'm just showing you where it is. And the best thing about this is the points for y equals 2 to the x. I now want the points for y equals log base 2 of x. And this is so beautiful. We don't have to plug it into a calculator. We don't have to do anything fancy about it. All we are literally going to do, because it's an inverse, is take the x and the y and flip them. So we're at 1/8 and -3. 1/4, -2. 1/2, -1. 1, 0. 2, 1. 4, 2. 8, 3. Because this was our base here, and now it's our base here, these two have a direct relationship. And I'll teach you more about inverses later. We're going to actually talk about how you solve an inverse and how you find an inverse and all that sort of stuff. But for now, all you need to know about inverses is to get the inverse of a function that is a base 2 to a log base 2, you literally take each ordered pair that we already found that were generally easy to find, and you flip them. So now when I graph this, and I'm going to graph this in green and I hope it shows up okay. So you can put those points on your page 131, but we're going to graph it on the same one as on 130. So don't listen to your Eureka because it wants you to graph it a bunch of different places and then graph it back on the same thing together. We're going to graph this still on this page 130 graph. So 1/8 and -3, that's just real close to 0. So it's like here-ish. Then at 1/4, we're at -2. At 1/2, we're at -1. At 0, we're at 1. Right? I'm sorry, at 1, we're at 0. My brain is backwards. At 2, we're at 1. At 4, we're at 2. 2, 3, 4, 2. At 8, we're at 3. And what happens is we get what is technically the flip or the mirror image, the reflection of the original. So this is the logarithm, and this is y equals log base 2 of x. And what I want you to notice is the log generally we'll get real close to 0, but not cross it, right? Because remember we talked about you can't get negative logs, or you can't take negative logs. And then it will increase, but it's not going to increase very quickly. Whereas the exponential gets really close to the x0 and then gets really big very quickly. But what you hopefully notice is they're very similar shapes. If I was a perfect human and a robot, they would be exactly identical reflections of each other. If you did this on paper and you wanted to, you could draw a line at 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1. You could fold on that line and you'd find that they land right on top of each other because they're reflections. Okay, we're going to skip the graph at 131. We don't need it right now. Then it wants you to go ahead, and I'm going to let you try this without me. It wants you to repeat this for 3 to the x. So what I mean by that is you're going to take that same idea, but instead of y equals 2 to the x, you're going to do y equals 3 to the x. And then you'll do y equals log base 3. So I'm going to go ahead and erase this. So let me pause for a moment. So anything you don't have written, you can get written. We will talk about this when I get back, but you are smart enough and you are capable enough that you can do some of this without me. I'm going to go ahead, I'm going to erase these pieces. And this is on page 131 now, I believe. No, 132. Where it's going to have you do now the log 3. Alright, so they give you the same table. Oh, they don't give you a table, I lied. I'm just going to do negative 2 to positive 2. I'm going to find out what this is, and then I'm going to do the point. Maybe I'll do the point here. And then I'm going to go ahead and do the flip. Right, so 3 to the negative second would be 1 over 3 squared, which is 1 over 9. So I get negative 2 comma 1/9. Therefore, the log version would be 1/9 comma negative 2. 3 to the negative 1 would give me 1 over 3. That'll give me negative 1 comma 1/3. The log version then is the flip. So I'll get 1/3 comma negative 1. Okay, you can do the rest of that table without me. Try graphing it and see what happens. Then throw your paper around if you want. Don't actually. All right, you are going to take a look at homework-wise, page 135. It's going to have you do a couple of different graphs like we did here with T-charts. All right, and then it's going to ask you to compare some values. Just do the best that you can on it. We're going to talk more specifically about it when I'm back. I am really sorry that I wasn't here this week. I don't know that you were disappointed to not do math, but yes, I know. I just got scolded to not pick up the paper because I'm not supposed to bend over after my surgery. Please be kind to my classroom, all right? Don't leave a mess for me. Push your chairs in, please. Be nice, clean up, all that sort of stuff. I appreciate it. I will be back Monday. Make sure you watch this video. Make sure you try the assignment. And when I get back, we'll deal with everything that happened while I was gone. All right? So have a good weekend. Have a good rest of your day. And if you feel like it, do some math. I'd appreciate it. All right. Bye.